So in this video it will make sense that if you have three non-collinear points. So what do non-collinear points mean? It means that if you have 3 points that are not in a straight line. If your 3 points are not in a straight line, you can make a triangle out of it. If 3 points are in a straight line, then this length plus the length between these 2 points, right, will be equal to the length from the first to the last point. So they are in a straight line. So triangle inequality will not hold. It will be like an equality, straight line equality. So if you have distance d1, if you have distance d2, and if you have distance d3, d3 will be equal to d1 plus d2. This is collinear. So if it is non-collinear, it's not in, then it will form a triangle. That's what it means. So they're saying in any triangle, there is only one circle that goes through all 3 points of a triangle. That's all this proof means. I think that's the first thing we should understand. Sorry, theorem corollary means. So how do we go about understanding that? So I think first thing we need to understand is about a circle. So in a circle, okay, let's say around here is the center. The center of the circle is such that if you have any point on it, which makes, let's say we're going to take a chord. Anyway, any point on it, the length from here to here is always radius. It's constant. So that is the property of a circle, right? So if I have a chord, then already we know that these 2 sides are the same. So this is the radius, yeah. If we have a bisector, which means if I bisect this, which means this side is the same as this side, right? And if I go ahead and connect the center to this, then we can see that due to SSS, this is the same, this is the same, this is the same. So this triangle is congruent to this triangle. They are the same. The 2 triangles are the same. And because it's a straight line, this angle plus this angle is 180. So I have drawn it as 90 degrees because it is. So if you have a bisector, not angle bisector, side bisector, this is a perpendicular bisector. So the perpendicular bisector of a chord goes through the radius. This is the second sort of obvious property when you look at a triangle, and it can be anywhere, right? The triangle, the point, let's say another point is here somewhere. Okay. So if that point is here, then if this is a chord, then its perpendicular bisector will also go through the center. In fact, this is how, if you have a triangle, so now you have 3 points, non-collinear, you can draw a perpendicular bisector of 2 of them, get the center, and you will get one circle, and only one circle, that will touch all 3 points. So this is the property. So to summarize, we had, you will always have, let's say, a distance 3 that is less than d1 plus d2. Any d, any of them you can take, or and the other way around. So you have the triangle inequality. When it holds, the points are non-collinear. Then we have used the fact that in a chord, the perpendicular bisector goes through the center, or basically the center to the line from center to that bisects the chord is a perpendicular bisector. Yeah. And so for any triangle, you will have a perpendicular bisector, right, and center of circumcircle. Circumcircle means that goes over it. In circle is the one inside, this is a circumcircle. It goes all around and touches all 3 points, goes through all 3 points. Sorry. So the chord is a perpendicular bisector that will go through the center, right? And the triangle, you will have two perpendicular bisectors you can take, any two. That will give you the center of the circumcircle, and then of course to any of all three will be the same distance. And it will cover all 3 points, and there is only one such circle.